In this video, we are going to explain everything about vectors. Let us start first by multiplication of vector by a real number. Look at this vector u. If you multiply the vector u by any positive constant number, then the two vectors, they are going to have the same sense. But if you multiply the vector by a negative number, the two vectors will have different sense. So as you see, u and ku, they have the same direction and the same sense. While in the second case, they have opposite sense because you multiply the vector by a negative number. So as you see, the length of a vector, you have to put the absolute of this constant outside because it should be positive if you are talking about same sense. For example, if you have the vector AB and you are asked to draw a vector D such that CD equals 2 over 3AB, you look at the constant number. If it's positive, then AB and CD should have the same sense. 2 over 3, so I'm going to get positive or the same direction. These are some properties for vectors. If you multiply two vectors by a constant, then you can distribute this constant among the two vectors. The same thing in the second property. If you are multiplying the vector by two constants, you can distribute also the constant. And if you are multiplying a vector which already have a constant number, then you multiply the constant numbers by each other beside the vector. Now we are going to talk about collinear vectors. When do I say that two vectors are collinear? I can say that two vectors are collinear if there exists a real number k such that the vector u equals kv. Then I can say that the two vectors are collinear. For example, if I have AB equals KAC, for example, AB equals 2AC, then definitely A, B, and C are going to be collinear, the points. Why? Because they have the same sense, the same direction, and the common point, so definitely the points are going to be collinear. Now, what about a midpoint of a segment? If I is a midpoint of AB, then for every point O we have OA equals OB, and I can say that OA plus OB is equal to the diagonal of the quadrilateral obtained. So OA plus OB equals OC, which is the diagonal of the quadrilateral OBCA. See, so I in this case is the midpoint of AB because we already know that any quadrilateral, the diagonals bisect each other. So now I have two properties. I can say that OA plus OB equals OC, and I can say that OA plus OB equals 2OI because I is the midpoint of OC. So I can say that OA plus OB equals 2OI. How to prove it? You know that AI equals IB because I is the midpoint, and AI and IB, they have the same sense and the same direction. So I can say that IA equals minus IB. Then IA plus IB equals to 0. Conversely, if there exists a point O such that OA plus OB equals to OI, then I is definitely the midpoint of AB. So I can use the converse of this theorem. Now we are going to talk about the center of gravity of a triangle. So ABC is a triangle and G in the plane of ABC. If I can find a point G such that AG equals 2 over 3 AA prime, then AG equals 2GA prime. So look at these three medians. They intersect at a point. We call this point the center of gravity of a triangle. So starting from now on, I can say that there are a lot of properties that you can use them. You can say that, for example, AG equals 2 over 3 AA prime, or AG equals 2GA prime, or GA prime equals 1 over 3 AA prime. But for the property of a center of gravity, you can say that GA plus GB plus GC equals to 0. So from the centroid to any vertex, or the sum of the centroid to each vertex, it's going to be 0. So GA plus GB plus GC equals to 0. So those are the properties that we used. So GA plus GB plus GC equals to 0. If G is the center of gravity, then for every point O, OA plus OB plus OC equals 3OG. Conversely, if there exists a point O such that OA plus OB plus OC equals 3OG, then G is the centroid of triangle ABC.